Okay, hello everyone. I'm Justin. I'm a third year medical student this year, and I'm going to talk about question 11 on the free 120 here. So, just some general goes and tips. If you haven't seen one of these before, thanks for listening to mine. Basically, we're going to talk through a question. I hope to give you all my thought process when approaching a new question I haven't seen before, and we're hoping to understand the correct answer as well. And then after that, we're going to talk through some general concepts. Maybe if you didn't get the question right or you need some more help with it, you can maybe read those to get some more information about it. But just a general tip I have when I approach every step one, even step two questions now, is you don't need to know everything to get the right answer. You can kind of piece some parts together, and if you don't know something, that's okay. You can sometimes get to the right answer. So, like I said, I'm talking about question 11 here in the free 120 of the 2024 version of it. But yeah, a 60-year-old man comes to the office with weakness, tingling of his hands and feet, irritability, and forgetfulness for 4 months. Physical exam shows pallor, weakness, and spasticity. Deep tendon reflexes are increased. Sensation to vibration is absent in the lower extremities. Laboratory studies show megaloblastic anemia, serum antiparietal antibodies, and increased serum concentrations of methylmalonic acid and total homocysteine, the synthesis of which of the following amino acids is likely impaired in this patient. So, like I said, lots of information. It seems like it's talking about neuro initially in the first sentence here with the weakness and tingling and irritability and forgetfulness. None of those are super specific to anything that I know about in neurology, but 4 months is important. I feel like with any diagnosis, you want to know how long it's been going on. Just gives you a time frame of, like I said, how long it's been going on. And physical exam shows pallor, weakness, and spasticity. Pallor you only really see when they're talking about anemias. So I'm maybe thinking like a possibly heme lymph, possible neuro thing, and spasticity, which is a lot more specific in the neuro symptoms. That's leading me towards an upper motor neuron disease as opposed to a lower motor neuron disease. So I'm thinking more brain and spinal cord issues. And it kind of seals the deal when they say reflexes are increased. That's only upper motor neurons. So we kind of can limit ourselves already to brain and spinal cord pathologies. On top of this, sensation and vibration is absent in the lower extremities, which tells us that not only is it a cortical spinal tract issue with reflexes being decreased, but also sensation vibration, which is the dorsal columns, are also decreased. I'm assuming it's a spinal cord issue, and it seems like kind of that's where we're leaning towards a little bit, with almost half of the back of the spinal cord being like cut essentially. Laboratories show megaloblastic anemia. There's our anemia to go with the pallor that we've got going up. Serum antiparietal antibodies, which I didn't know off the top of my head how that relates to anything. So I didn't really think of that initially. I just kind of put a question mark and was going to come back to it later. Increased serum concentrations of methylmalonic acid and total homocysteine, which is important with a megaloblastic anemia. And then the question's talking about synthesis of amino acids. So it's ultimately a foundations question, but it's bringing in all of this heme lymph and neuro to get there. So, like I said, we know that it's a spinal cord issue, or we're assuming it's a spinal cord issue because the reflexes are increased and dorsal columns are knocked out as well. And laboratory shows a megaloblastic anemia. So, with that thinking, with those two systems in mind, I was thinking maybe a B12 deficiency. And that would also play in this weakness, the tingling of the hands. It would show all those neurological signs. And it's kind of like a nail in the coffin for me when they show methylmalonic acid and total homocysteine, because I know that was a big talking point in the megaloblastic anemia section of heme lymph. And so yeah, I'm kind of thinking either folate or B12, but I know B12 causes neurological symptoms. So I know it's a B12 deficiency without even knowing what antiparietal antibodies are. So now the question is the synthesis of which of the following amino acids is impaired in this patient. So it's asking us how B12 affects the pathways of these 5 amino acids. So off the top of my head, I know tyrosine is used for the production of dopamine. That's one of their pathways that it could be used for. And if we have a decrease in dopamine, we're going to have a Parkinson's-like patient. So the rigidity, the bradykinesia, like those type of symptoms, and we're not getting this. We're showing hyperreflexia here. And I also know that phenylalanine is also related to the tyrosine pathway. I think phenylalanine can be made into tyrosine, but again, don't really know that off the top of my head, but it's just a thing I can rule out if I know it's a part of that world. We're not talking about this one right now. Glutamine I know is also a part of, well, not a part of the TCA cycle, but it feeds into the TCA cycle. So if we were to have an absolute deficiency of glutamine, like no glutamine in the body anywhere, the effect on the TCA cycle would be decreased ATP, which would be decreased energy, which would not show the increased reflexes or this anemia that we have going on. I can't really make that connection in my mind, or that connection would be too many steps that the question writers wouldn't want us to make. So I'm left with cysteine and methionine. I know homocysteine is written in the question, obviously, and cysteine's a part of homocysteine. I can't really remember if cysteine comes above or below homocysteine, but I do know that methionine is needed. B12 is needed for methionine synthesis, so I would lead to my final answer being methionine, even though I can't necessarily rule out cysteine completely. And that is the right answer. So a quick review here, vitamin B12, also called cobalamin. It's used in lots of pathways for lots of things in the body, but specifically for this specific question, it converts homocysteine to methionine. And this is straight from a slide from the heme lymph section. It's the hyperproliferative anemias. Also, B12 is used for sectional CoA, but that information wasn't really needed for this type of question to be answered. And in general, like I already talked about the folate and B12 deficiency, you can determine neurological symptoms from it. B12 would have neuro symptoms and folate wouldn't. But also another laboratory test that you can run is this methylmalonic acid, which they did give us, which B12 is increased and folate is normal. In folate deficiency, it's normal then. Going back to the question, I had this question about what the heck antiparietal antibodies are and how I didn't need that information. But if I know that this is kind of where they're leading anyway with B12's absorption and stuff, parietal cells are found in the stomach, parietal cells produce acid, but also produce intrinsic factor. So if you don't have any parietal cells, it would cause a decrease in intrinsic factor, which again, going back to GI now, would be used for vitamin B12 absorption. So that, again, just plays into the fact that we know they're vitamin B12 deficient already, but that just gives us one little extra tidbit. So things to possibly review, I kind of separate this question into two separate areas. You need to get the diagnosis right first, and then you need to understand how B12 deficiency impacts the biochemical pathways. So if you didn't get the pernicious anemia, which is what the antiparietal antibodies are, I would read up on, well, first pernicious anemia, of course, and the B12 metabolism and absorption pathways, specifically with intrinsic factor and how that is complicated by antiparietal antibodies. That'll go into the pernicious anemia more so. Lab studies to determine megaloblastic anemias. We talked about a little bit with folate having a normal methylmalonic acid level, but vitamin B12 has an increased MMA level. And the intersection of neurology and anemias, this is, I would say, the biggest point where they intersect, but there's a couple more intersections that you can also look up. I believe it's covered a lot in the first aid neuro section, so you can read over that. And if you did not get the specific biochemical pathway, which is what this question was asking, and I felt like it was a lot more specific, that just kind of like a tidbit of information you should know or don't know sometimes, I would just read up on the methionine cycle in general for this specific question, obviously. And the role of B12 in various pathways. I think first aid has another table where they lay out what B12 is used in, specifically the folate cycle and the methionine cycle, and a couple more. But those are high yield facts because they, instead of talking about methionine, they could talk about another pathway that could be implicated because of this. And then just in general, the methionine cycle and the folate cycle interact a lot. So seeing that, how they all correspond and how they go together, you can get a question like that as well. But yeah, that's all I could think about possibly reviewing for this question. Thank you so much for listening. If you have any questions, you can contact Emily Scanlon, or you can even set up another meeting with me and we can talk about it more if you want to. And you can find that on the peer coaching webpage. Thank you.